I'm really happy that we are moving forward with session 12 of our cognitive neuroscience from basic foundation to pragmatic clinical applications course. We are in session 12 and we are going to talk about sleep and cognitive neuroscience of sleep. That is something that I'm really interested to talk about, and we will see how that might make you interested to this field as well. So we are going to discuss about 6 major topics today. We will talk about sleep and our daily functioning and cognitive functioning. We will talk about how we do studies in sleep. We talk about phases of sleep. We will talk about neuromodulators, and then we will talk about sleep and memory problem-solving issues, and also we will talk about dreaming. So these are the major topics that we are going to cover today in the class. Okay, let's think about the sleep and our daily functioning, and think about sleep in a sort of evolutionary sense. Thinking about, okay, what are the pros and cons of sleep for our ancestors? In terms of just thinking about when they had to sleep during the night, they probably would be sort of defenseless. So they would be very vulnerable during night, because technically when they are asleep, any predator could target them. So there are lots of kind of challenges in terms of going to sleep. So you can imagine that the sleep from the evolutionary sense of view could not be something very fit for our ancestors, because of the amount of time that they had to spend without being able to do something for kind of being able to feed themselves or providing things for their family. But that is quite an interesting kind of evolutionary process, that why, with all the negative aspects of being slept for a while during night and becoming a target for all the predators in the environment, at the end of the day, in the process of evolution, sleep developed, and now we have such a kind of strong biological basis for sleep that it's getting really hard for people to just avoid getting into a sleep, and there are lots of consequences if you want to avoid sleep. So how sleep evolved in the process of evolution, and why we right now we need sleep in that kind of serious way. It is really hard to find anybody who is able to not sleep at all, and there are lots of negative consequences if people are interested not to sleep. So why we have such an interesting part of the life? Is it just because during the night time people were not able to do anything, and that was the best way of, let's say, not spending energy and just kind of passing that amount of time that is totally dark? There was totally dark, something like 5,000, 10,000, kind of 20,000 years ago, and just kind of saving energy during the night time, or it was something beyond that, or there are lots of other applications for being able to sleep in the evolutionary sense. So we'll talk about those aspects together. But before getting to that, I just have few questions, and I was thinking that we might be kind of interested to discuss about some questions that might be interesting for you as well. So let's just start with these questions. So you already have a Google Doc, so you are able to share the Google Doc. So let me just give people an idea about the questions that we have. So we're going to ask you 5 questions, and at the end of the day, we just collect the information and share the database with everyone. So I hope that people can just, I think that we probably can just anonymize the database and share the database with you to just explore it yourself. So even we can discuss about the results next week to see what are the relationships that we have inside the database, and think about how sleep could be assessed, and what are the interesting aspects of sleep that we can explore. First of all, with the first question, you're okay, you have already shared the link. Okay, so oh, that's good. So the link is, so we are not going to publish anything from that, so it is not a study or it is something that we are evaluating about you. It's just something like an exploration that we are doing inside the class. But let's start with this question in terms of are you a regular day napper? And we define regular day napper as a person who is taking a nap every day, almost every day during the week, something like 5 days per week. So that is how we define regular day napper. So are you a day napper or not? That is one question. The second question is talk about how you define yourself, whether you are somebody who is just awake during up to midnight or even after midnight and doing lots of different things after 9 p.m., or you are an early bird who is out of bed something like 6 a.m., 5 a.m., 4 a.m., and is able to do lots of things early in the morning, or it is not the case for you to be a night owl or early bird. So you can just, it is hard for you to define how is your sleep pattern, whether you are an early morning riser or you are a late night person. So it is hard for you to define. So you have three options for that. And then the next question would be how much you proactively use sleep to solve your problem. In terms of thinking about, okay, I already have a problem, let me just sleep over this problem and find the solutions tomorrow morning. So how much, or do you use that as something like a way to solve the problem? So it is something like a routine or common practice for you to just try to solve your problem during the sleep and try and considering sleep as a way to solve the problems. It is the case for you or not? This is the third question. And then the fourth question would be, have you ever experienced sleeping behind the wheel? So there are people who have experienced sleeping behind the wheels, and there are people who says that, I mean, we have never experienced kind of being able to sleep behind the wheels. So when you are driving, have you ever kind of felt that you are just napping while you are driving? So thinking that kind of you can put yourself in something like a dangerous situation because of just napping behind the wheel. And it seems that there are people who are easily napping behind the wheels, and there are people who never nap behind the wheel. So that is quite interesting dichotomy, that if you are in one group or the other group. And third, I mean, the fifth one would be, do you feel sleep deprived right now? Just feeling that you are already sleep deprived or not. So this is the last question that we're going to ask. Do you feel that you are sleep deprived or not?
Also, sorry, there's another question that you told me to add, and it's about how many hours of sleep do you get usually every night?
Exactly. So, and I'm probably just asking whether people are male or female, so that
I that specify the gender question.
Yeah, we can. I'm not sure. Yeah, if you want to say gender, I mean, just kind of giving people a clear idea when we talk about gender or sex. When we talk about sex, we are talking about what people have between their legs. And when we talk about gender, we are talking about what people have in their brain in terms of their identity. And when we want to say gender, I mean, technically from the kind of the experimental point of view, we need to provide other options, just other than male and female. I'm not sure if we have. You did? Okay, sounds good. Okay, sounds good. So it's not binary. Okay, sounds good. So we have those questions, and yeah, we can explore that later on together. I'm not sure if Panyan would be able to just provide something like an overview, or Mohsen could just give us an overview about the result at the end of
I'm analyzing the data real time, so it might take about a minute.
Fantastic. Sounds great. So if everybody would be able to just fill in the form, so then we will be able to have the results as well. So then we can see how is the outcome. So we can just wait for a few seconds, making sure everybody is making that.
Okay, the results are ready. The ones who responded to the survey until now. So
how many responders do you have right now?
So about 57. So are you also seeing the GoToMeeting panel, because it's quite disturbing for me? But okay.
No, it is.
So as you're saying here, the first question, most of you are not daily nappers apparently, and about the second question, you can see, so you're neither night owls nor early birds. So, and also The third question, you seem not to proactively sleep over problems to solve them. And so 21% of the participants said that they have experienced sleeping behind the wheels, whereas 79 said that they haven't. So, and also, 75% of the respondents said that they're not sleep deprived. They're not feeling sleep deprived right now, but 25%, including me, told that they are sleep deprived right now.
Yeah, I can imagine,
Yeah.
because you had a panel yesterday, right? I mean, you had the panel Friday. You had the panel.
Yeah, on Friday. Yeah.
On Friday, okay.
Yeah.
And they had.
But I was going back and forth.
Okay, yeah.
Yeah.
Yeah. So okay,
So,
good.
and the next question, most of you, 68% told that they get 6 to 8 hours of nice sleep, which is quite healthy, excellent. And others, as you can see, one person said that they sleep more than 10 hours, one person less than 4 hours, and then 19% said that they get 8 to 10 hours of sleep, and 9% said that get 4 to 6 hours of sleep. Okay, and then most of our participants, the respondents, were female, and yeah.
That is interesting. If you refresh that, how many more we have right now?
Yeah, sure. So, are you? You're still. Oh, yeah, okay. You're still seeing that. You're not seeing the R, are you? Yeah.
Are we? Yeah, we are seeing the R as well. Yeah.
Oh, so okay. This is the updated version.
Okay, 67 people right now have done that. Okay, sounds good. So, I mean, at least we have a sense about the variation that people have in these questions. And you can imagine, I was thinking that you can even think about some other questions that would define how people are doing their sleep, and there are definitely different aspects of a sleep, and we will talk about the sleep. So now you have a better sense about what are the topics that we are going to discuss about today. Okay, sounds good. So let's go for the slides. We all know that when we have lack of sleep could be related to many aspects of our health. Lack of sleep could be related to higher sensation of pain. It could be related to cardiovascular disease. It could be related to risk of cancer. There could be lots of metabolic problems and lack of immunity, and also things related to diabetes, which is related to metabolic problem as well. So we know that with there are some somatic responses when we have lack of sleep, and there are different aspects of our somatic functions that would be affected by lack of sleep. And then in terms of the emotional responses, there are a huge amount of evidence that we could be exhausted, irritable, we can have mood fluctuation, we can have depressed mood, we can have a significant problem in what we call hypothalamic pituitary adrenal axis, or HPA axis, in terms of response to stress, and the level of cortisol that is related to this axis could be impaired. And also we can have anger, impulsivity, decreased motor performance, alcohol use. And people know that there are lots of, let's say, sort of behavior that are more prevalent when we are sleep deprived, and kind of things like risk-taking behavior and impulsivity. So these are the things that are happening when we are pretty much sleep deprived. So these are the consequences of being sleep deprived, and people have tried a lot in terms of how sleep deprivation could be associated with different sort of decision-making problems and so on and so forth. Even in terms of the different cognitive functions, we know that attention, memory, executive function, decision-making, all of those aspects could be highly affected by sleep deprivation. So we all know these challenges. But in reality, the question in terms of how lack of sleep could impair our brain function is a complex question to answer. So compared to the previous part that we have been discussing about the consequences and the problems that we could suffer from because of the sleep impairment, the second part that we are discussing about right now in terms of, okay, how lack of sleep could make all these problems is a more complex question to answer. And we still do not clearly know how really sleep deprivation could make a significant impact in our sleep, in our daily function. So that there are lots of definitely lots of kind of questions that we still don't know. But there are things that we know, so we will discuss about some of those aspects today. As we discussed in terms of the evolutionary sense, it seems that during the night time, we are using the amount of time that we have during night in being able to, first of all, save energy, which is sleeping. But the other issue is that we are probably doing some housekeeping issues in the brain in terms of cleaning up different things, removing toxins, helping different elements in the brain to be fixed, or there could be some recovery processes during the process of sleep. So we think that there are different functions that are happening during the process of sleep. But it seems that there are some other additional values for sleep that we'll discuss about. In terms of, it seems that our sleep, our cognition is not gonna work without sleep, and there are specific functions in the cognitive process that are shifted to be happening during sleep, and we cannot just ignore them. So we will discuss about some additional values for sleep. But clearly these two items have a significant evolutionary benefit for our ancestors, and now that is the reason that we already have kind of such a kind of huge kind of sleep impact in our biology. And even in cities like, I mean, when you go to places like Manhattan or places like Shanghai, those places you can easily see that people can easily not to sleep during the entire day, because there are many places that are open 24/7. So now the lifestyle is in a way that we can even, especially in larger cities, even in places like, let's say, Mexico City or Tehran or Mumbai, in kind of those kind of large cities around the world, you can see that you can easily just do whatever you like to do during the entire day. But obviously, even with this kind of new development or new changes or new environment or contextual changes around the world, we are still taking the sleep pattern of spending at least 8 hours, 9 hours, 10 hours for all these functions. It seems that these functions are really hard to be replaced by any other kind of alternative. So we'll discuss about some of those functions together today. It seems that people agree that there are at least two major mechanisms involved in the process of sleep control. One mechanism is called what we call the circadian rhythm. We'll discuss about that. And the other is what we call homeostasis. So homeostasis and circadian rhythm. So these two processes, one is called process C or process S, but these two mechanisms are playing a significant role, and it seems their interaction is making us to go to bed or not. So that is the process of these two interactions. And what do we mean by homeostasis? When we talk about the homeostatic aspect of the process, is that when we are wakeful, over the time we develop to have higher level of, let's say, toxins and unwanted materials in the brain, and we develop what we call sleep depth. So we start to develop a depth in terms of accumulating different materials in the brain or in the body that should be removed during the sleep time, over the process of sleep. And we need to go to sleep because we need to have some housekeeping issues happening while we are asleep to clean up those materials. So we do that because we need to keep the equilibrium of different materials in the body, and to be able to keep the equilibrium and being able to metabolically balance inside the body, we need to have sleep because of this kind of hemostatic needs, or the needs that we have in terms of the metabolic changes in the brain and body, and we need to go to sleep to be able to recover and just kind of clean up the system to be able to go back to the normal function. So that is what we call homeostatic change. But the other mechanism is called circadian change, or circadian mechanism, or circadian regulation, which is another kind of mechanism which is not about the metabolic changes or the need that we have for sleep. It's about a system that is kind of adjusting itself based on the day and night shift in the external environment. And those who have experienced things that we call jet lag in terms of traveling across time zones, they realize that it's not just about need for getting to sleep. Sometimes we just know that we are just out of sleep right now, but because of the circadian rhythm that we have, and because right now when we are kind of out of bed, in our local time it is something like midnight, even when we know that we really don't need a kind of more sleep because we have already been in bed for something like 8 hours, we just feel that we are exhausted. So there are mechanisms that would be interested to put us in a sleep during the kind of the middle of the night, even when we really do not need the sleep. So that is another mechanism which is interacting with the homeostatic mechanism. So these two mechanisms are interacting to each other, and they work together to be able to put us in sleep. And most of the time they are supposed to work together. So we are supposed to have them both together to be able to have a better sleep. And it seems that these two mechanisms are being controlled with two completely different neural and chemical pathway. It seems that this circadian mechanism is being controlled by what we call melatonin. So melatonin is sort of a hormone that is being produced inside a gland in the brain. We'll talk about that. We call it a pineal gland. And this specific hormone would make what we call the circadian rhythm. But the hemostatic mechanism, it seems that it is related to what we call adenosine. And I'm not going to go to the biochemistry details about that, but we know that we have an accumulation of adenosine over a time, and the higher the level of adenosine, the higher level of fatigue that you will feel. So the higher level of adenosine would be contributing to the level of fatigue that you have. And it is quite interesting that we have an adenosine blocker that basically block adenosine receptors, so then the adenosine signal of fatigue would not be received in the cells after blocking that receptor. And this adenosine blocker is called caffeine. So we know that caffeine is blocking adenosine receptors, and that is the reason that when we get caffeine, we still are developing the amount of adenosine that we have in the brain, but we are not perceiving of being fatigued. So we basically block this mechanism that is gonna inform us or alarm us that we need to get to sleep, and we just accumulate the level of adenosine without perceiving the level of fatigue that we have. And that is the reason that when we get a caffeinated drink, whether it's coffee or energy drinks or whatever we have these days, they can make you feel less fatigued. That is the reason. But we still have let's say the melatonin mechanism in place, and as I told you, these two mechanisms are working together and hands in hands to be able to make a high quality sleep for you. But in terms of having a sense about how melatonin system is working, we know that the system is working through a a nucleus in the brain which is called suprachiasmatic nucleus, SCN. And suprachiasmatic nucleus is a nucleus that is above what we call the optic chiasm. And optic chiasm, I will talk about that later. We have discussed about that before in terms of when we have kind of the optic nerves, they would cross each other in a place that we called optic chiasm, and then they would go to thalamus and then to the visual cortex. We discussed about that before. But this nucleus is on the top of the place that we have as optic chiasm, and that is called suprachiasmatic nucleus. But there are some interesting facts about this specific nucleus in the brain. The figure seems a little bit complex, so let me walk you through the figure and help you to understand what is really happening here. First of all, we have a devoted neural pathway from the retina to hypothalamus and to suprachiasmatic nucleus from the eyes. So we have a specific neural pathway that is coming from retina in the eyes. It's called retino because it comes from retina. And then it goes to hypothalamus and what we call suprachiasmatic nucleus in hypothalamus. So we call that retino-hypothalamic tract. So this is the pathway that would bring information regarding that whether it's dark or it is just daylight outside. So that is the information. And then the information would go through the spine, so it goes down up to something like cervical spine, and then from cervical spine it would go back to the brain to an area that we call pineal gland. And pineal gland would secrete melatonin when things are dark outside. And this is not just about secreting melatonin when it is dark outside. It just learns when the outside is gonna get dark. So even when you are in something like a place that there is artificial light, so you are not exposed to, let's say, darkness of outside, you still secrete melatonin at the time that you are supposed to secrete melatonin. So the system is informed by the light from outside, but it also learns how to arrange the timing of the secretion, even when there are days that you are not receiving that input from the optic nerve. So that is the interesting pathway for this really interesting gland that we have that we call pineal gland. The other really interesting thing about pineal gland is, this is located here in the human brain. But when you go to mouse, the pineal gland is located here, which is pretty much close to the surface of a skull. But the pathway that I told you is almost identical in human and in mice. So we both have the same pathway. But in the evolutionary sense, when you go down from rat to the lower levels of animal, when you go to the kind of reptile brain, in reptile brain, the pineal gland would even be out of the skull, and it would go even something like under the skin. So if it is the skull, the pineal gland would go out of the skull and would be kind of under the skin, and it could receive extra light from outside. And that is the reason that we call it third eye, because it receives directly information from the outside environment. And that is the reason that is kind of helpful to be able to make different circadian rhythms. But over the time in animals, when we have a kind of a higher evolution and we have a larger cortex, because cortex would just grow out of these areas, it would just basically hide pineal apple pineal gland, and the pineal gland would just go down, as you can see here in human in us as human. So you can see it goes down, and it's not now exposed to light, but we still have a specific pathway that would go to hypothalamus, to the spine, and being back from that to pineal gland to be able to kind of give information about the daylight or the darkness outside to the pineal gland. So that is how this system is working. And that is the reason that when you go to new places, that you need to kind of update the pineal gland function. First of all, it is kind of, you are recommended to run outside or walk outside in the daylight in the new place that you just arrived. And also you are recommended to even take melatonin in the night time, because technically your body is not secreting melatonin during the night time in the new place, especially when you travel over the seas. For example, you travel from US to Europe or to Asia, or I mean when you have something like 10 hours, 8 hours of time difference, you definitely need kind of extra assistance to be able to regulate this system again, to bring it back to a normal functioning. And this is how we basically have a different timing of the year, of the day, working in different functions, whether it is noon, afternoon, night, morning. And people have different cycles for that. So there are different studies in terms of what would be the effect of this, what we call circadian rhythm, in our different sort of biological functions, whether it is about, let's say, the melatonin secretion. So we know melatonin secretion would stop at something like 7 a.m. in the morning, and then we have the highest testosterone level in 9 a.m. in the morning. We have the highest blood pressure in the afternoon, or the melatonin secretion would start at something like 9 p.m. It is probably not for me. I probably would start to secrete melatonin from something like 8 p.m. I mean, there are definitely lots of personal differences in this regard as well. But you can see that people have clear timing of the day, how different functions are working. And things like even bowel movements are highly related to what we call this circadian rhythm. And things even like cardiovascular and muscle strength are highly related to the timing of the day. But meanwhile, you can still train yourself to be able to have better, let's say, cardiovascular function early in the morning. So for example, I just have a far better kind of muscular ability early in the morning, because I train my body and I inform my body that I need to kind of run early in the morning, because it is not going to work for me in the afternoon because of the kind of daily schedule that I have. So now I have a better cardiovascular function early in the morning. So people have different, let's say, circadian rhythm. And it's quite interesting that even in different age, you have a sort of different variation of this, let's say, rhythm. And as we saw today, that people can have different variations. There are people who are early birds. So they, for example, me, I just wake up something like today, I just woke up 4 a.m. in the morning, and I had an online meeting at 4:30 a.m. in the morning till 6:30. I had two back-to-back meetings, and then, I mean, I was preparing the slides for the class today. So it's just pretty much kind of starting my day from something like 4:30 a.m. in the morning, and then going through that. But I mean, people are quite different in terms of, and I cannot work after something like 9:30 p.m. So I just go to bed something like 9:30 p.m. So that is the routine way that I do, and people are quite different. And it seems that there are specific genes that are running inside different families. Like, for example, in my family, we have two basically lines. My brother is completely against me. I mean, he's sort of an old person, so he can just sleep, kind of work up to something like 2 a.m. in the morning, but I've never experienced that before. So I clearly remember that when I was preparing, I mean, when I was in the first years of medical school, and he was just started his law school. We have been. When I was preparing kind of a presentation for my presentation, I was just preparing things something like till 9 p.m. And then he was helping me in putting slides together. He was starting things at something like 9 p.m. till something like 3 a.m. in the morning. And then I was out of the bed when he was just going to bed, and I was kind of receiving the slides from him to be able to make them. So it's quite interesting that how even two brothers could be quite different in terms of their functioning, and I can easily see that in different family members. So I can easily follow that among my parents and my uncles and my aunts, so to see how they are quite different in terms of these sort of they call clock genes, and how these clock genes are managing this process, and observing how they are different from each other, and observing the variations that I have in my family is quite an interesting experience. So one of the things I usually recommend people is just kind of try to see how these specific, let's say, traits are running into your family, and try to see what is the kind of the sort of pedigree of these biological traits inside your family. Okay, so that was the first part of our class today, discussing about the sleep and the impact of sleep, and the process of kind of learning about sleep and its characteristics.